This is 4.6, related rates, page 2. Starting at this example right here, the radius r and surface area s of a sphere are related by s equals 4 pi r squared. Write an equation that relates ds dt and dr dt. Now notice this over here has no t's in it, which means we're going to have to differentiate with respect to t. And especially since these have dt's in it, we're going to have to find a derivative with respect to t. Let's start right here at s equals 4 pi r squared. When we do a derivative on the left, ds dt. On the right hand side, this 4 pi is a constant multiple. That 4 pi comes down. And then the derivative of r squared is 2r times dr dt. And cleaning this up, ds dt is 8 pi r dr dt. And that's it. We're done. Write an equation that relates ds dt and dr dt. We have ds dt is 8 pi r times dr dt. Done. If we look at this next one, the volume of a cone is related to the base radius and its height by volume is 1/3 pi r squared h. Remember your geometry formulas. This time we want to know how dv dt is related to dh dt if r is held constant. So we'll start here. V equals 1/3 pi r squared h. And if r is held constant, then along with this 1/3, this pi and r squared, that's all constant. So when we do the derivative with respect to t, dv dt, this 1/3 pi r squared, all constant multiple, that comes down, times now the derivative of h, dh dt. And that's it right there. How is dv dt related to dh dt? dv dt is 1/3 pi r squared times dh dt. All right. How is dv dt related to dr dt if h is held constant this time? So we'll start again. V is 1/3 pi r squared h. And this 1/3 pi still constant. But now also this h constant. When we do the derivative, dv dt, all the constant multiples, 1/3 pi h. Now the derivative of that r squared, 2r times dr dt. And cleaning this up, dv dt, looks like we have 2/3 pi rh times dr dt. And right there, how is dv dt related to dr dt? Well, dv dt is 2/3 pi times r times h times dr dt. And the last one down here, how is dv dt related to dr dt and dh dt if neither r nor h is held constant? So we'll start off with v equals 1/3 pi r squared h. We want to do a derivative. Nothing's held constant, so we're going to have a product rule here. 1/3 pi r squared, first part, h, second part. The derivative, dv dt, first, 1/3 1/3 pi r squared times the derivative of the second, dh dt, plus the second, h, times the derivative of the first. And in this first one, that 1/3 pi r squared, the 1/3 pi is constant multiple, that comes down. The derivative of the r squared, 2r, dr dt. And cleaning this up, 1/3 pi r squared dh dt plus 2/3 pi rh dr dt. Do you notice that this answer down here to C is the sum of the answers from parts A and B? And here's why. If we look at this one, the 1/3 pi r squared dh dt plus whatever this one is over here, if r is held constant, then dr dt up here in this big long list would have been 0. The derivative of a constant is 0, so that part drops off, and then all that's left is the first part. If h is held constant, then when we did the derivative of the first times the derivative of the second, the derivative of that h would have been 0. So this piece drops off, and we're left with that much. Thank you very much. Make sure you tune in for the rest of the pages in this unit.